All right, let's talk about Python functions. In this explainer, we're going to peel back the layers on one of the most fundamental, most important building blocks in the entire language.
First, we'll cover the absolute basics, what they are and why you should care. Then we'll look at how they handle their own data and how we pass information into them. After that, we'll get into some more advanced stuff like decorators, and we'll wrap it all up with the art of writing functions that are actually clean and readable.
Okay, let's dive right in. What is a function, really? And why do we even bother using them in the first place?
You can think of a function as a reusable recipe, right? You write down the steps just one time, you give that recipe a name, and then you can cook it whenever you want just by calling its name. It's all about that core principle of don't repeat yourself, which, is absolutely key to writing good code.
And notice this crucial detail right here. You have to define the function, in this case, mySum, before you can call it. It's like trying to teach someone a new word before you use it in a sentence. Python has to learn the recipe before it can actually follow it.
So what's the big deal? Well, functions are basically our best friends when it comes to organization. They help us avoid that copy and paste nightmare where you have the exact same 10 lines of code in 5 different places. You just write it once, you perfect it, and then you can reuse it everywhere. So much cleaner.
So to quickly sum up this first part, functions are just reusable blocks for specific tasks. They make your code way more readable, and you absolutely have to define them with that def keyword before you can use them.
Okay, so we know how to create a function, but what happens to the variables we create inside of it? Do they just exist everywhere in our code now? Well, no. And this brings us to the super important concept of scope.
So to find a variable, Python follows this really clear search pattern called the LEGB rule. It's kind of like looking for your keys. First, you check your pocket. That's the local scope. If they're not there, you check the room you're in, the enclosing scope. Then the whole house, that's global. And finally, you check if they're just part of the door lock itself, which is the built-in scope.
Now this is where it gets really interesting. Look at this. When we change the variable a inside the function, it doesn't touch the global a outside of it. It creates a brand new local variable instead. That's why the function calculates 10 plus 20 and not 100 plus 20. It looks in its local pocket first.
But check this out. If we use the global keyword, we're explicitly telling Python, hey, I don't want a new local variable. I want to change the one out there in the main script. And look how the result changes completely. Now it reaches out, changes that global A to 100, and uses that for its math.
So let's recap scope. Variables live in different namespaces. Python finds them using that LEGB rule: local, enclosing, global, built-in. And if you really need to, the global keyword lets you break out of that local scope.
Okay, so we know how functions find variables, but how do they receive them in the first place? This gets us to another crucial concept: how we pass arguments. The way Python passes data into functions, it all depends on the type of data. There's this fundamental split, right? Some types, which we call immutable, are passed like a safe copy. Others, called mutable, are passed more like a direct, live link to the original. Let's see what that really means. And here is a fantastic way to think about it. Immutables, like numbers or strings, are like postcards. You get a copy, you can read it, but you can't change the original message that was sent. Mutables, like lists, are like a shared Google Doc. Anyone with the link can make edits, and everyone sees those changes.
In this example, just illustrates the difference perfectly. Inside our function, we try to change both the string and the list. And you can see in the output, the name Bob, our postcard, was totally unaffected. But the list, our shared Google Doc, was permanently changed.
So to wrap this section up, the main thing to remember is this: be really careful when you pass lists and dictionaries into functions. The changes you make inside can have side effects everywhere else. Numbers and strings, on the other hand, are always safe.
All right, now for something really powerful. What if you could change how a function behaves without ever changing its code? Sounds kind of like magic, right? Well, welcome to the world of decorators.
Now, the magic behind decorators all comes down to one core idea in Python. Functions are treated as first-class citizens. What that really means is you can pass a function into another function as an argument, just like you would pass in a number or a string. They're not special, they're just another type of data.
So a decorator is basically a function that takes another function as its input, wraps it up in some extra logic, kind of like gift wrap, and then returns that newly enhanced function for you to use.
And that little @ symbol you always see before a function definition, that's just what we call syntactic sugar. It's a clean, simple shortcut for that whole wrapping process. It just makes the code a lot easier to read. So, in short, decorators are only possible because functions are objects. They let us add new features without touching the original code, and that little @ symbol makes it super easy to do.
We've covered a lot of the mechanics, so let's finish up with the craft. How do we write functions that don't just work, but are actually clear, clean, and easy for other people, and our future selves, to maintain?
You know, writing readable functions isn't about some secret trick. It's really just about building good habits. And if you only take one thing away from this slide, let it be this. Give each function one single clear job. A function that calculates taxes should not also be emailing a receipt. That principle right there is the foundation of clean code.
And speaking of documentation, let's talk about type hints for a second. It's so important to understand that they are exactly that. They're hints. Python won't stop your code from running if the types are wrong, but they are an incredibly powerful way to communicate your intentions to your teammates and to your code editor, and they can prevent a whole class of bugs before they ever happen.
So the next time you sit down to write a function, just pause for a second and ask yourself, will the person I am in 6 months have any idea what this does? From using a clearer name to just adding a simple docstring, what's one small change you can make to your very next function to make it just a little more readable? Your future self is definitely going to thank you for it.